in this video, we discuss all the 4 multiple choice questions on the topic relations. These questions has appeared in the joint entrance examination main in the January 2024 session. That is, the examinations, the JEE main examinations that are held from 27th January 2024 to 1st February 2024. We discuss all the 4 multiple choice questions on the topic relations. We first discuss the first question. This question has appeared in the 27th January 2024 morning shift examination. The problem is, let S is equal to the set consisting of 1, 2, 3 up to 10. Suppose M is the set of all subsets of S. The relation R defined as the set consisting of ordered pair A comma B, where A intersection B is not empty and A comma B belongs to capital M, is, we are given 4 options. The options talk about the reflexive, symmetric and transitive property of the relation R. We are given a set S consisting of 10 natural numbers, that is 1, 2, 3 up to 10, and you are also given M is the set of all subsets of S. That means M is the power set of S, and the relation R is defined as the set consisting of ordered pair A comma B, where A intersection B is not empty and AB belongs to M. We now discuss the solution of the problem in detail. Given S is the set consisting of 1, 2, 3 up to 10. We are also given M is the set of all subsets of S. M is the set of all subsets of S means M is the power set of S. We are given the relation R is equal to, it's a relation on M. That is, it is given as the ordered pair A comma B, where A intersection B is not empty and A comma B belongs to M. That is, for AB belongs to M, A related to B by the relation R, if and only if A intersection B is not empty. That means you take any 2 elements of M, that is, they are power set, they are the subsets of S. A and B are subsets of S, and they are related if there is something common between them. So we have discussed the reflexive, symmetric and transitive properties of R. We first take the easiest in this case is the symmetry. For AB belongs to M, A related to B, A capital R B implies A intersection B is not empty. Now we know the intersection is a satisfies commutative law. A intersection B is equal to B intersection A. Therefore, this will imply B intersection A is also not empty because the intersection is commutative. That means B is related to A. This says when A related to B by the relation capital R, then B is also related to A. This means the relation R is symmetric. Okay. Now we talk about the reflexivity. Now How do we judge reflexivity? If R is reflexive, then A related to A for all A belongs to M. That means every capital A belongs to M is related to itself. Then it is said to be reflexive. Now, is R reflexive? Now, here we see phi belongs to M. Why? M is the power set of S. Power set of S means it contains all subsets of S. So the empty set is also a subset of S. Therefore, the empty set phi belongs to M. And phi intersection phi is phi. Therefore, the relation R is not reflexive. Why? Phi intersection phi, if it is not equal to phi, then they are related. So, because it is equal to phi, therefore phi is not related to itself. So, this means phi related to phi is false, is not true. Phi related to phi, if it is, then phi intersection phi is not equal to phi, but it is equal to. Therefore, phi related to phi is not true. So, R is not reflexive. Agreed. We go for transitivity. Let A is equal to the set consisting of 1, 2, B is the set consisting of 2, 3, and C the set consisting of 3, 4. Then A, B, C belongs to M because they are subsets of S. Agreed. Now see, let us see A intersection B is the 2 is common. Therefore, it's not empty. B intersection C, there is a 3 common. So, it's not empty. But whereas A and C, if you see, there is nothing common between A and C. The A is not related to C by the relation R. So, this implies A related to B, B related to C. But A is not related to C because A intersection C is nothing in common, that is empty. So, A is not related to C. That means the relation R fails to be transitive. So, this tells you the relation R is not transitive. Thus, we have seen R is symmetric, R is not reflexive, R is not transitive. So, R is symmetric, just symmetric only. Let's look at our options. So, thus, the relation is symmetric only. Let's look at our options. So, our answer, symmetric only, appears against option 4. Therefore, the answer to this question is option 4. So, that is the detailed discussion of the solution of the problem on relations. I am sure that you have understood the solution of this problem. We will now move to the second question. This question has appeared in the JEE Main 29th January 2004 examination, and this exam was held in the morning session. The given question is, let R be a relation on Z cross Z defined by. Now, it is on the Z cross Z. Who are the elements of Z cross Z? All ordered pairs A comma B. A belongs to Z, B belongs to Z. So, the relation is defined on Z cross Z as A comma B is related to C comma D if and only if AD minus BC is divisible by 5. Then R is, again we have to discuss the reflexive, symmetric and transitive nature or the transitive property of the relation R. Agreed. Now, let's look at the problem once again. R is a relation on Z cross Z defined by A comma B related to C comma D if 5 divides AD minus BC. Then what are the properties of R? That's the question. We now discuss the solution of the problem in detail. We have Z, the set of integers, and we have Z cross Z, the set of all ordered pairs x comma y, where x, y belongs to Z. Agreed. Now, how capital R is defined? Given R is a relation on Z cross Z defined by A comma B related to C comma D by the relation capital R if and only if 5 divides AD minus BC. So first we see whether it is reflexive or not. For all A comma B belongs to Z cross Z, we have A comma B or A comma B. Why? Because 5 divides AD means AB minus BC, that is BA. So 5 divides AB minus BA, which is 0. So 5 divides 0. So therefore, every ordered pair A comma B in Z cross Z is related to itself. So thus R is reflexive. Move to the second, that is, we discuss the symmetry now. A comma B related to C comma D by the relation R if and only if 5 divides AD minus BC. This will imply 5 divides minus of AD minus BC. So if 5 divides 10, 5 also divides minus 10. So 5 divides AD minus BC will imply 5 divides minus of AD minus BC. This implies 5 divides minus of AD minus BC is CB minus DA. So that means this implies C comma D is related to A comma B by the relation R. So you can check. So 5 divides CB minus DA implies CD is related to A comma B by the relation R. So it says C comma D related to A comma B whenever A comma B is related to C comma D. So this tells you that R is symmetric. We move on to the transitivity. Now we go by a situation where transitivity fails. Now let us say 1 comma 0 is related to 0 comma 5. Is it so? Yes. Why? AD minus BC, first you see 1 into 5 AD minus BC 0 into 0 0. That means AD minus BC is 5. So 5 divides AD minus BC here. Therefore 1 0 is related to 0 comma 5. And 0 comma 5 is related to 0 comma 1. AD is 0 into 1 0. BC 5 into 0 0. AD minus BC is 0. 5 divides 0. So 0 comma 5 is related to 0 comma 1 is also true. But is 1 comma 0 related to 0 comma 1? Let's see. 1 comma 0 AB, CD is 0 comma 1. So AD 1 into 1 minus BC 0 into 0. So AD minus BC is 1. Now will 5 divide 1? No. Therefore 1 comma 0 is not related to 0 comma 1. Therefore it tells you thus R is not transitive. R is not transitive. So thus R has these properties. R is reflexive, symmetric, but not transitive. So that's the property of R. So let's look at our option. So our answer R is reflexive and symmetric but not transitive appears against option 3. Therefore the answer to this question is option 3. That is the detailed discussion of the solution of the problem on relations I am sure that you have understood the solution of this problem. Let's now move to the next question, that is the third question. This question has appeared in the JEE Main Examination held on 29th January 2024 in the second shift. The given question is, if R is the smallest equivalence relation on the set consisting of 1, 2, 3, 4, such that the set consisting of ordered pair 1, 2, 1, 3, the ordered pair 1, 3 contained in R, then the number of elements in R is. So it's given a set consisting of 4 elements, the set of 1, 2, 3, 4. And given R is and we have to find out we have to find out a relation R, which is the smallest equivalence relation on this set containing the set consisting of 2 ordered pairs 1, 2 and 1, 3. If R is that such a smallest equivalence relation, then the number of elements that are present in this R. So we are given 4 options. So here are the options given to us. Let's now discuss the solution of the problem in detail. Given the set capital A is equal to 1, 2, 3, 4. Now we want to find n of R, that is the number of elements that are present in R, where R is the smallest equivalence relation on A, such that the set consisting of ordered pairs 1, 2, 1, 3 is contained in R. So we are given the set A consisting of 1, 2, 3, 4, and we have to find out that relation R, which is the smallest equivalence relation on A, such that R contains these 2 ordered pairs 1, 2 and 1, 3. Then in that case, we want to find n of R. So we recall the definition of an equivalence relation. A relation R on A is an equivalence relation R if it satisfies all the 3 properties, that is R is reflexive, symmetric and transitive. Now we have to extend the set consisting of ordered pairs 1, 2, 1, 3 by including minimum number of ordered pairs such that the extended set is an equivalence relation capital R on A. So what is that we have to take? We have to do, you take the ordered pair, you take the set consisting of the ordered pairs 1, 2 and 1, 3 and extend this set by including minimum number of ordered pairs in such that the extended set is equivalence relation R on A. So that we will explain you by this table. So we have A is the set consisting of 1, 2, 3, 4. Let us say B is the set consisting of ordered pairs 1, 2, 1, 3. And this set is to be extended to an equivalence relation by including the minimum number of ordered pairs. So first of all, our goal is to extend this set to an equivalence relation. The equivalence relation should have all the 3 properties: reflexivity, transitivity and symmetry. So first, we want to achieve reflexivity. To do so, we adjoin ordered pairs 1, 1, 2, 2, 3, 3, 4, 4. So we adjoin these. Now B is extended to the already 2 elements. Now the new 4 elements are here. Now let us see the extended set. Is it an equivalence relation? Reflexivity is achieved But what about symmetry? So we talk about 1, 2 is there, 2, 1 is not there, 1, 3 is there, 3, 1 is not there. To get, to extend to an equivalence relation, the symmetry should be there. So to achieve symmetry, we adjoin these two elements, 2, 1, 3, 1. So 1, 2 will give you 2, 1, 1, 3 will give you 3, 1. So now the adjoin already extended set. Now the new extended set is the old one and the new ones are in blue. Now we ask the question. Is the transitivity achieved? No. Now suppose you take 2, 1 and we have 1, 3. 2, 1 composed with 1, 3 will give 2, 3. 2, 3 is not in this set. So it's a new element. So to achieve the transitivity, what we do is we take 2, 1 here, 2, 1 and compose that with 1, 3. So 2, 1. Suppose you compose with 1, 2. You will get 2, 2 which is already there. So 2, 1 compose with 1, 3 is 2, 3. Now 2, 1 if you compose with this 1, 1 it will remain 2, 1 only. 2, 1 compose with this will not give you anything. So the composition with 2, 1 is over. So let us take 3, 1. Now take 3, 1. Compose with 1, 2, you will get 3, 2 which is a new element. So 3, 1 with 1, 3 is 3, 3. So don't do that. So you get these two. So the 2, 3 symmetry to achieve, you will get 3, 2 which is already there. So adjoin 2, 3, 3, 2 with this. So thus we got these elements. Now is it an equivalence relation? You check now. Reflexivity is there. Symmetry is also there. 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, 3, 2. Symmetry is there. Transitivity is achieved here. So the transitivity we got here. So how many elements are there? This is the equivalence relation extended. So this equivalence relation contains this B. So R will be the equivalence relation, required equivalence relation consisting of these elements. Right. So this is the smallest equivalence relation containing B, that is the set consisting of ordered pairs 1, 2 and 1, 3. Therefore, the number of elements present in this equivalence relation are 10. So 2 plus 4, 6 plus 2, 8 plus 2, 10. So let's look at our options. The number of elements in that equivalence relation is 10. So the answer to this question is option 4. That is the detailed discussion of the solution of the problem on equivalence on relations. I am sure that you understood the solution of this problem, and we move to the next question. That is the fourth question. That is the last question. And this question has appeared in the JEE Main examination held on 1st February 2024 and in the second shift. The given question is, consider the relations R1 and R2 defined as A related to B by the relation R1 if and only if A square plus B square is equal to 1 for all A comma B belongs to R, where R is the set of real numbers. And how R2 is defined? A comma B related to C comma D, the ordered pairs, by the relation R2 if and only if A plus D is equal to B plus C. For all ordered pairs A comma B, comma C comma D belongs to n cross n, where n is the set of natural numbers. Then what are the options? The options talk about the equivalence, the property of equivalence relation of R1 and R2. So various options are given. Is R1 and R2 both are equivalence relations, or neither R1 nor R2 is an equivalence relation? Only R1 is an equivalence relation, or only R2 is an equivalence relation? So look at the definition. Agreed. We move on. So that's the problem. We now discuss the solution of the problem in detail. We are given R1 is a relation on the set of real numbers defined by A R1B if and only if A square plus B square is equal to 1 for all AB belongs to R. Now, we test the reflexivity. A R1A, that is A related to A, if and only if A square plus B square is A square is equal to 1. That is, if and only if 2A square is equal to 1. If and only if A square is equal to 1 by 2. If and only if A is equal to plus or minus 1 by root 2. That means an element A from R will be related to itself by the relation R1 if and only if that element is plus or minus 1 by root 2. That means if A is chosen not equal to plus or minus 1 by root 2, then A is not related to itself by the relation R1. This implies A is not related to A when A is not equal to plus or minus 1 by root 2. That means A is related to A for all A is not true. Therefore, R1 is not reflexive. When R1 is not reflexive, R1 is not an equivalence relation. So that is the property. That is the equivalence relation. Property is not there for R1. We move to R2. Given R2 is a relation on n cross n defined by where n is the set of natural numbers. A comma B related to C comma D by the relation R2 if and only if A plus D is equal to B plus C for all ordered pairs A comma B comma C comma D belongs to n cross n. Now let us test the reflexive nature. A comma B related to A comma B if and only if A plus B, A plus D is equal to B plus C, B plus A. Yes. In the set of natural numbers, commutative law is true. Therefore, A plus B is equal to B plus A for all A comma B. So this will tell you this relation is satisfied for all A comma B, the ordered pair belongs to n cross n. So that means every ordered pair of n cross n is related to itself. Therefore, R2 is reflexive. Let's go for the symmetry. A comma B is related to C comma D implies A plus D is equal to B plus C. This implies B plus C is equal to C plus B because plus is commutative in the set of natural numbers is equal to A plus D. A plus D is equal to D plus A. So this will imply C plus B is equal to D plus A. So this will imply the ordered pair C comma D is related to the ordered pair A comma B by the relation R2. So whenever A comma B is related to C comma D, C comma D is also related to A comma B. So this will tell you R2 is symmetric. Now we talk about transitivity. A comma B is related to C comma D, means A plus D is equal to B plus C. And C comma D is related to E comma F, means C plus F is equal to D plus E. Now adding, what do we get? A plus D plus C plus F is equal to B plus C plus D plus E. So after cancellations, the cancellations take place. Now DD cancels, CC cancels. So you will get A plus F is equal to B plus E. That means A comma E is related to A comma B is related to E comma F. Why? A plus F is equal to B plus E it is. So this means A comma B is related to E comma F. So A comma B is related to C comma D and C comma D is related to E comma F will imply A comma B is related to E comma F. Thus R2 is transitive. Thus R2 is reflexive, symmetric and transitive. Therefore R2 is an equivalence relation. So what is that we have proved? R1, therefore only R2 is an equivalence relation because R1 is not an equivalence relation. So let's look at our options. Our answer appears against option 2. Therefore the answer to this question is option 2. So that is the detailed discussion of the 4 solutions, 4 multiple choice questions that have appeared in the January 2004 Joint Entrance Examination Main. I am sure that you have understood the solutions of these 4 examples and I wish you all the best. Thank you.